Okay, now we derive a formula for the surface area of S. This time with S having equation z equals f of xy defined over a region R in the xy plane. So to do that, we actually just use the fact that such a surface in this scenario can be parameterized. It has actually a natural parameterization given by r of xy equals x, y, f of xy, where xy will vary over this region R in the xy plane. Ayan, so meron tayong parameterization. So ang gagawin lang natin, i-apply lang natin yung formula for the surface area na dinerive natin earlier. So dito, we have this parameterization na x and y ang parameters. So we apply the same thing, may iba lang yung letters na ginamit natin. So first, let's compute r sub x. With this r sub x is 1, 0, f sub x. Okay? And similarly, r sub y is 0, 1, f sub y. Tapos getting the cross product, okay, yung first component ay negative f sub x, yung second component ay negative f sub y, tapos yung third component ay 1. Ayan, so we have this. Tapos, just rewriting this expression, let's recall z is f of xy, so itong f sub x saka f sub y can be rewritten as partial of z with respect to x saka partial of z with respect to y. So ito na yung cross product. So with that, we have the following formula for a of s. Just applying this a of s will be the double integral of the norm of this vector, which is this expression. Inuna lang yung 1. So square root of 1 plus partial of z with respect to x squared plus partial of z with respect to y squared. So we get the double integral of this function over r. So again, dito, ito na yung formula natin. Dito, yung z dito, yun yung f of xy, yung equation ng galing sa equation ng surface. Tapos yung r dito ay yung region sa xy plane kung saan defined si f of xy. Or in other words, yung region r ay yung projection nitong z equals f of xy sa xy plane. So, to apply this formula, kailangan alam natin yung dalawang bagay na yon, yung surface, nakasulat as z equals f of xy, at saka yung region R, which is the projection of that surface onto the xy plane. Okay, so ito na yung formula. Okay, so let's do examples. First, let S be the portion of the plane 3x minus 2y minus z plus 6 equals 0 that lies above the region enclosed by the parabola y equals x squared minus 4 and the line y equals x plus 2. So with those, in that scenario, find the area of S. So before we move to the solution, let's first visualize kung ano yung nangyayari dito. So meron tayong plane in R3, tapos meron tayong dalawang curves na nagde-describe dun sa region in the xy plane. Okay, so yung curves na yon, parabola at saka line. Ayan, so we have this. So meron tayong isang parabola at saka line, mag-intersect sila, tapos yung region bounded, yun yung region natin sa xy plane. So region to sa xy plane. Tapos, again, merong plane na given, di ba? Pero hindi yung buong plane yung gusto natin hanapan ng surface area. Ang hahanapan natin ng surface area ay yung portion lang daw nitong plane na to na nasa taas lang ng region. So, ito yun. Okay, yung portion lang ng plane na nasa taas ng region na define sa xy plane. Ayan, so in the end, we want to find the area of this red surface. Okay, so we have the following scenario. So again, yung R na to, region sa xy plane, defined by these two curves. Tapos, merong portion ng plane. So dahil portion lang ng plane to, yung equation niya, same pa rin. Pero this time, i-rewrite natin yung equation na yun as z equals f of xy. So ginawa natin yun kasi ganun yung assumption dito sa formula na i-apply natin. Ayan, so we have yung S, alam na natin yung z equals f of xy, alam din natin yung region R in the xy plane. Well, may rough sketch tayo. So para mas malinaw, usually nakatulong kung sketch natin separately itong region R na to. Okay, so for the solution, we find the area of the portion of this surface over this region R. So kailangan nyo lang i-sketch yung region na yun. So siguro alam nyo na yung graphs ng y equals x squared minus 4 tsaka y equals x plus 2. Tapos you can verify on your own na mag-i-intersect sila sa points na to. Sa negative 2, 0 tsaka sa 3, 5. Ayan, so malinaw na sa atin kung ano yung region R na nasa xy plane. alam din natin yung z equals f of xy na gusto natin hanapan ng surface area. So with those, apply lang natin tong formula. So the surface area is given by the double integral of square root of 1 plus partial nitong z with respect to x squared, so 1 plus 3 squared, plus partial of z with respect to y, tapos square nun. So, plus square ng negative 2. So, yung integrand this time is square root of 1 plus 9 plus 4, which is square root of 14, which is constant na pwedeng ilabas sa double integral. So, ang natira na lang sa atin, ang kailangan natin i-evaluate, double integral ng 1 over this region R. Well, nasabi natin before na double integral ng 1 ay equal sa area ng region R. Pero for this particular example, if we try to use that fact, mukhang wala tayong patutunguhan kasi totoo, since totoo naman, even though na totoo na equal tong part na to sa area ng R, okay, the thing is, medyo irregular yung shape ng R. Wala tayong formula for the area of such a region. So, dahil dyan, wala tayong choice for this example, kundi mag-set up ng bounds para mag-evaluate itong double integral na to. Okay, so since dahil ganito yung itsura ng region, mukhang to evaluate this double integral, mukhang okay gumamit ng vertical strips. So, using vertical strips, dy dx, integral to ng 1, dy dx from the lower curve, y equals x squared minus 4 to the upper curve, y equals x plus 2, tapos x is from negative 2 to 3. Ayan, so ito na yung setup ng double integral. The rest is just a matter of evaluating this iterated double integral. So, integrate first with respect to y, evaluate sa endpoints, simplify, integrate with respect to x, evaluate sa endpoints, then simplify. Ayan, so ito na yung area ng surface S na yung red surface kanina sa earlier slide. So again, to apply this formula, kailangan naka-Cartesian yung ating naka-Cartesian equation yung ating surface, in particular nakasulat as z equals f of xy, yun yung applyan natin ng partial derivative with respect to x with respect to y. Tapos kailangan din, alam natin yung region R sa xy plane, yung projection sa xy plane. Okay, as another example, let's find the surface area of the portion of the cone z equals square root of x squared plus y squared in the first octant between the cylinders x squared plus y squared equals 1 and x squared plus y squared equals 4. Okay, so dito, kung papansin nyo, walang region in the xy plane na binanggit dito. So, para ma-apply itong formula, well, alam na natin yung z, portion daw nitong cone. So, ibig sabihin, ito na yung applyan natin ng formula dito sa integrand. So, ang kailangan na lang natin malaman ay yung region R. Para malaman yung region R, since hindi siya given, kailangan alaman natin siya by sketching what's happening here. So, again, ang given sa atin dito ay isang cone, as portion lang daw between these two cylinders, at saka nasa first octant lang. So, let's visualize that. So, we have this cone. Tapos, we have two cylinders, x squared plus y squared equals 1, tsaka x squared plus y squared equals 4. Tapos, yung portion lang daw ng cone na nasa gitna ng dalawang cylinders na to. So, ito na lang, kung may imagine nyo, ito na lang yung matitirang portion. So, ito na lang natira. Tapos, sabi, yung portion lang daw in the first octant. So, further cutting the surface, ito na lang yung matitira, yung portion na nasa first octant. Yan. So, we have the sketch of the surface that we are trying to find the area. Ang kailangan na lang natin ay yung projection nito sa xy plane. So, again, yung projection, yung shadow nito sa xy plane. Pero take note, yung projection niya will be this region. Tapos, itong dalawang curves na to, galing to dun sa intersection ng cone with these two cylinders. So, dahil dyan, itong dalawang to ay actually circular curves tong dalawang to. Galing kasi sila again dito sa circular cylinders na to. So that yung projection will look like that. So ito na yung scenario sa ating problem. Okay. So we have the following sketch. Okay, so again yung S here is the portion of this cone. So equation niya, yung same equation ng cone, portion lang naman siya. And this is the region R defined by the intersections of this cone with the cylinders with these equations na since yung cylinders have these equations, that's dalawang circular curves lang tong dalawang to. Okay, so ayun, na-recognize na natin what is the surface tsaka yung region R. So we can proceed with applying the formula. Okay, so we find the portion, the area of the portion of z equals square root of x squared plus y squared above this region R. Okay, so itong region R na to, galing dun sa equations ng cylinders. So galing sa equations nila, itong circular curves na to have radius 1 and 2. Okay, ayan. So with that, let's apply this formula. So the surface area is given therefore by the double integral of square root of 1 plus partial of z with respect to x, which is, di ba? Square root muna, 1 over 2 square root of x squared plus y squared. Tapos chain rule times 2x. So you can imagine, magka-cancel yung 2. So we have this. Okay? Plus, tapos square na, no? Plus partial of z with respect to y. So again, yung 1 over 2 square root. Tapos sa taas, may times 2y. Tapos square nun. Ayan, so ito yung integral natin. Simplify muna natin siya. So take note, itong first two terms, pag square natin to magiging x squared over x squared plus y squared. Ito y squared over x squared plus y squared. Tapos, you can imagine na lang, pag kinumbine itong dalawang terms na to, magka-cancel, di ba? Magiging 1 na lang sila. So, yung integrand actually is just, in the end, 1, square root of 1 plus 1. So, square root of 2 na constant na pwede ilabas sa integral. Ayan, so, in the end, we just want to find the double integral of 1 over this region. Okay, this time, yung region R natin is just, 1/4 of a region between two circles. So, dahil dyan, we can apply again yung concept na ang double integral ng 1 ay equal sa area ng R. For this example, okay gamitin to kasi familiar na geometric object itong R natin. Ayan, so without setting up bounds, we can evaluate this. Pero kung hindi nyo maiisip yun, hindi naman mali na pwedeng mag-set up ng bounds dito using polar coordinates. Okay? Pero using this approach, hindi na natin kailangan mag-set up, hindi rin natin kailangan mag-integrate. So anyway, continuing this approach, square root of 2 times area of R, we get square root of 2 times 1/4 ng area ng outer circle, pi 2 squared, minus area nitong inner circle, pi 1 squared. Ayan, so simple computation lang using simple geometry. So this simplifies to this number, 3/4 square root of 2 pi. And that's the area of the portion of the cone that we illustrated earlier. Okay, so that ends our lecture on applications of double integrals. So again, using double integrals, we can find the volume under the surface. We can find the area of a region. And actually, we can use that same equation to evaluate the double integral of 1 without setting up bounds. And also, we computed using double integrals the mass of a lamina and its center of mass. And we computed two surface area formulas. Okay, so pakialala, may dalawang formulas for surface area. One for parametric surfaces and one for Cartesian equations. Okay, so with that, sana natutunan natin at na-appreciate na maraming pwedeng i-applyan ng double integrals. Okay, so that ends the lecture. Thank you for listening.